Hi, today we're going to be demonstrating the physics of throwing a basketball through a hoop. This project was created by 4 high schoolers, Aufia, Jahnavi, Samiha, and Emily. Before we go into the specifics, it is important to familiarize yourself with all of the Newton laws. Newton's first law states, an object at rest stays at rest with the same speed and direction unless acted upon by an unbalanced force. Newton's second law deals with acceleration. Acceleration is produced when a force acts on a mass. The greater the mass, the greater amount of force needed to accelerate. Newton's third law states, for every action, there's an equal and opposite reaction.
Newton's first law relates to moving a basket because unless you actually put an applied force to a basketball, it will not move. Likewise, if a basketball is moving, it won't stop moving unless forces such as gravity and air resistance act against it. Newton's second law is applicable because a basketball is a set mass. Because of this, a certain amount of applied force is needed to accelerate it. If a basketball was heavier than it was, more applied force would be needed to reach the same velocity. Newton's third law is related because once someone throws a basketball in the air, other reactions work to counteract the basketball's movement, including the horizontal and vertical components of gravity.
The average basketball weighs 625 grams. Because of this, the force of gravity acting upon it is 6.13 newtons. This can be done by a simple calculation. Other forces to take into account are applied force, which acts in the direction of motion, and air resistance, which acts in the opposite direction as motion. Depending on the distance from the hoop, a certain angle and velocity will be needed for the basketball to hit the net. Velocity is essentially the same thing as speed and is measured in meters per second. When you first throw a basketball, the speed with which it first moves is its original velocity. For example, if a 7-foot player was 14 feet away from a 10-foot hoop, he would need to throw the basketball with an original velocity of 3.72 meters per second at an angle of 55 degrees to make the shot in 2 seconds.